How are we doing, guys? We're looking at text and test 4, chapter 1.6, page 23, questions 4, 8, 13, and 15. I'm going to start off here with question 4. Verify that 5 minus 5 is equidistant from the line x minus 2y plus 10 equals 0 and 2x plus y minus 30 equals 0. Equidistant means the same distance from. So this whole exercise is based around this formula here. And the use of it, that is the distance of a point xy from a line that's in the form ax plus by plus c equals 0. So here's our line where a is 1, b is minus 2, c is 10. Okay, and we want to know how far that point 5 minus 5 is from this line here. So using our formula, our perpendicular distance, and that should say perpendicular distance, is going to be the absolute value of a, which is 1, multiplied by x. So here's x and y. That's 5. Plus b, which is minus 2, multiplied by y, which is minus 5. Plus c is plus 10. All divided by the square root of a, which is 1 squared, plus b, which is minus 2 squared. Okay, so what's that going to be? 5 plus 10 plus 10, that's 25 over the square root of 5. Okay, and I'm going to leave it at that. You could simplify it. I think that simplifies. Well, I think that's 5 root 5. So we're asked to show that this point is the same distance from two lines. This one and the other one we've been asked to work with is 2x plus y minus 30 equals 0. So the perpendicular distance of 5 minus 5 from that line is going to be the absolute value of twice 5 plus b now is 1, y, which is minus 5, minus c is minus 30, all over the square root of a squared is 2 squared, plus that number in front of y is 1, so 1 squared. Okay, so that's going to be 10, take away 5 is 5, take away 30 is minus 25, over, again, the square root of 5. Okay, now, I should have left those absolute value signs in there. They make no difference to that answer here. The absolute value signs mean the answer comes out still as 25 over root 5. So it's always the positive value, and that's 5 root 5. So equidistant, the same distance. We've shown that both of those lines are the same perpendicular distance from the point 5 minus 5. And the fact that has a positive distance inside the absolute value signs, and this has a negative distance inside the absolute value signs, shows that they're on opposite sides of the line. Okay, so or of the point, sorry. So one of them is here, the other one's here, essentially. Question 8. Find the values of a if the perpendicular distance from the point minus 2, 3 to the line ax plus b plus y minus 7 equals 0 is root 10. Values because there are two lines that are that perpendicular distance from a. Let's have a look at them. The first one, it's a x plus y minus 7 has to have a perpendicular distance of root 10 from the point minus 2, 3. So there's our distance formula. All over a is a squared plus y is 1. Or sorry, b, excuse me, is 1. So that's 1 squared. So solving that, we're going to get the absolute value of minus 2, take away 4, excuse me, that's minus 2a, take away 4, all divided by root a squared plus 1 equals root 10. Multiplying through here, we get the absolute value of minus 2a minus 4 equals root 10 by root a squared plus 1, which is the same as root 10a squared plus 10. Now, squaring both sides here. So squaring is a good way of getting rid of these absolute value signs. If you want to get rid of them, they say it has to be a positive number. All square numbers are positive. So square that, and we can get rid of them. We can say, well, it's 2a minus 4 squared equals, square that, and you get 10a squared plus 10. Squaring that out, we're going to get 4a squared plus 16 plus 16a. And that's 10a squared plus 10. Move everything over to the right. 0 is 6a squared, 10a squared minus 4a squared, minus 16a, and then 10 take away 16 is minus 6, which is the same as 3a squared minus 8a minus 3, if we divide left and right here by 2. And that factorizes as 3a, I want minus 8a, so minus 3, that gets me minus 9a plus 1a. Okay, so there's it factorized, and a is either 3, according to this one, or a is minus 1/3. Okay, so we've got two possible answers there for the value of a, because there are two lines that are a distance, perpendicular distance, root 10 from the point minus 2, 3. Question 13 asks us, write down the equation of any line parallel to 4x plus 3y plus 1 equals 0. So let me just show you, if I have any equation in the form ax plus by plus c equals 0, if I want to get the y by itself, I might say by is minus ax minus c, and that y then is minus ax over b minus c over b. Okay, so there's your slope. Any line like that is going to have a slope minus a over b. And you can use that anytime you want. You can say the slope is minus a over b if it's in that form. But more importantly, any line that shares the same a and b values here will have the same slope. So to write down a line parallel to this one, all that matters is that I have 4x plus 3y plus, let's say, 17 equals 0. It doesn't matter what number you put in there. The 4x and the 3y are the important ones. So write down the equation of any line, done. Hence find the equations of the two lines which are parallel to that line, 4x plus 3y plus 1, and 2 units from it. Okay, so there's two lines we're looking for here. We know that the perpendicular distance from our line, so in general, our line is going to be 4x plus 3y plus some number. I'm going to call it p equals 0. And we want to say a line that's parallel to this one, done, and 2 units from it. Okay, well, to work that out, really, we don't look at distances from a line to another line. We normally say from a point to another point to another line. So we need to find a point on this line so we can use it later on in our formula. So one point on that line would be, let's see, if that's 1, that'll be 3 plus 1 is 4. It'd be nice if that was minus 4. So minus 1, 1, okay, is on that line. That gives us minus 4 plus 3 times 1 is minus 1 plus 1 gives 0. So that's a point on the line. So what we are saying now is the perpendicular distance from our line, 4x plus 3y plus p, all divided by the square root of 4 squared plus 3 squared, needs to be 2. That's what we were told in the question, and it's the perpendicular distance from our line here to this point that's on this line. Okay, so minus 1, 1. So what do we get here? Well, that's going to work out as minus 4 plus 3 is minus 1. So that's p, take away 1, all over, that's going to be 5 equals 2. So p take away 1 equals 10. So either p take away 1 is 10, or p take away 1 is minus 10. So p is 9, or p is minus 11. So the two equations we want are 4x plus 3y plus 9 equals 0. There's one possible answer. or 4x plus 3y minus 11 equals 0. So those are 2 answers. Okay, last question, question 15. Write down the equation of any line through the point minus 4, 2. Hence find the equation of the 2 lines through that point whose perpendicular distance from the origin is 2. Okay, so a line through that, well, we don't know anything about the slope of the line, so the best we can say is y minus y1, which is 2, equals m times x minus x1, well, that's minus 4, so it's going to be x plus 4 that goes in there. Using our equation of the line formula, where m is some unknown. We don't know the slope. And writing that in the form ax plus by plus c, well, y minus 2 is mx plus 4m. And moving everything over, 0 is mx minus y plus 4m minus 2. So there's the line that we're interested in. Its perpendicular distance from the origin, which is 0, 0, needs to be 2. So we're going to say the absolute value of mx minus y plus 4m minus 2 all divided by the square root of m squared plus negative 1 squared has to be 2. And that's the perpendicular distance from this point here, 0, 0. So that gives us the absolute value of 4m minus 2 all over the square root of m squared plus 1 has to be 2. So squaring both sides will get rid of both this absolute value sign and also this surd. So if I square both sides, I'm going to get 4m minus 2 squared over m squared plus 1 equals 2. And then cross multiplying, I'm probably going to finish off over here. We're going to get 4m minus 2 squared equals 2m squared plus 2. Okay, we'll multiply 2 by this. And that is 16m squared plus 4 minus 16m equals 2m squared plus 2. 14m squared minus 16m plus 2 equals 0. So there's the equation we want to solve. Let's see, 7m squared minus 8m plus 1 equals 0. So how will that factorize? 7m and m. We want a 1 and a 1. We want a minus 8. So minus and a minus equals 0. So m equals 1 from here, or m equals 1/7. So our possible equations of a line are from here, either 0 is 1x minus y plus 4 minus 2, which is x minus y plus 2. There's one possible equation. Or the other possible equation of that line would be 0 equals 1/7 x minus y plus 4 times 1/7 minus 2. Okay, so multiplying through by 7, I'm squeezing it in down the bottom here. We're going to get 0 equals x minus 7y plus 4 minus 14, or x minus 7y minus 10 equals 0. So those are our two possible equations for the line. Now I'm going to ask you tonight, please, to work on page 23. Can you do questions 2 and questions 5? Tomorrow in class we're going to be looking at 3, 6, 9, 12, 14 and 16. Okay, see you tomorrow. Thank you.